Heat emitted from LED bulb. While LEDs do create heat in the strictest sense, significantly less power is lost in the production of heat. LEDs are therefore not only high energy efficient, but also significantly easier to utilize in thermal sections of your house without sacrificing the light, brilliant appearance. Heat emitted from pressure cooker. Heat is quickly transferred to the surface of any meal that is not immersed in liquid using high-pressure vapor. Usually, a spring-loaded vent is available to allow air to escape. When the heater is turned on, the expanding vapor pulls this valve up, shutting the exhaust. Heat emitted from overused mobile. Overheating can be caused by utilizing the phone camera for long periods of time, operating the phone at highest screen brightness, or playing graphically demanding games. If you use your smartphone often or constantly, the CPU will have to run all the time, resulting in a lot of heat. Likewise, utilizing the phone camera for an extended period of time causes the camera, CPU, and screen to operate continually, generating heat. The heating is spread across the phone's body. As a result, demanding apps like gaming can usually result in a nice and warm phone. In essence, whatever consumes a bunch of computing energy will lead your cell phone to overheat. The heat is evenly distributed throughout the phone's body. But demanding applications aren't the only ones to blame. Suboptimal settings might also result in considerable heat production. The display brightness has already been mentioned. Whenever it refers to suboptimal smartphone options that enable your smartphone to overheat, this is one of the most common reasons. In addition, bad mobile network conditions force the cell phone to constantly search for signals, leading it to overwork and create a lot of heat. Heat emitted from iron. Nichrome is utilized as a heat source in electric irons. It has a nickel-chromium alloy that has 80% nickel and 20% chromium. It has a melting temperature of 1,400 degrees Celsius, which is rather high. Almost any metallic wire may be used to generate heat, however, because most metals transmit electricity so well, they must be fashioned into very thin/fragile wires in order to provide enough opposition to produce heat. When warmed in the air, most metals soon oxidize, become brittle, and shatter. Nichrome wire, on the other hand, generates an outer coating of chromium oxide if warmed to red-hot degrees. Heat emitted from hair dryer. Hair dryers with maximum and minimal heat settings adjust the warmth of the air circulation by varying the energy delivered. These are built with a switch that allows you to turn off a piece of the circuit that supplies the heating generator. The length of time that the air in the dryer barrel is warmed by the circuit. Usually, hair dryers limit this to around a half second to prevent the air temperature from becoming too excessive. Hair dryers contain a heat detector that shorts the circuit and switches off the engine when the heat gets too high, ensuring that the air flowing out of the barrel never approaches this degree. The shutoff switch on this hair dryer, like many others, is a basic bimetallic strip. Heat emitted from straightener and curler. Curlers and straightening iron heaters are all heated by electroheat equipment that uses current circulation to heat the radiator, which is then transferred to an aluminum sheet or a ceramic wafer. Currently, the curler on the market and the heaters of a hair straightener control warmth with push keys, one of which can achieve a high-grade heating up warmth after pushing, and the remaining key can acquire low-grade warming temperatures after pushing. Because of the absence of a temperature indicator on the curler of this construction or the heaters of a hair straightener, individuals are unable to intuitively understand its warming heat gear. Heat emitted from microwave oven. Microwave ovens employ electromagnetic energy to make meals. The oven's non-ionizing energy does not render the food radioactive. Once the oven is switched on, a microwave appears. The warmth created by the radiation generated within the oven is received by the foodstuff and used to cook it. Heat emitted from AC. Between the evaporation and the condensing, a compressor pumps a warmth transmission liquid, or refrigerant. The refrigerant is forced via the loops, piping and fins by the pump. In the interior cooling coil, the fluid coolant evaporates, removing heat from the air and chilling your home. The heated coolant vapor is pushed externally into the reservoir, where it cools and goes back to a fluid, releasing its heat to the outer air passing through the metal piping and fins of the condenser. Heat emitted from television. The heat created by the LED backlight positioned at the bottom or sides of the TV is highly evident since LCD TVs are narrow and the cabinetry shell is tiny. The heated heat is a natural part of the process and should not be a consequence of worry. Heat emitted from Campfire. The fire's heat emission expands out in all ways and is capable of reaching you. Infrared rays and visible lights are the primarily common forms of heat emission. Convection warmth from a bonfire, on the other hand, travels straight up into the atmosphere and never touches you, i.e. hot air billows upwards. Heat emitted from hot tea. From a teapot, hot tea is poured into a cup. Your cup has a pleasant warmth to it. The heat was transmitted from one thing, the cup, to another, your hand, that being in contact with it in some way. This is an instance of transmission, one of three methods for transferring heat. Radiation emitted from refrigerator. When the device achieves the target heat, the voltmeter turns off the power and ends the HFC cycle in the pipe, thereby stopping the chilling action. This is the spinning noise you typically notice from refrigerators as they turn on and off. The highest quantity of electromagnetic energy is produced by the circuitry in the backside of the device that drives the HFC via the pipe. Radiation emitted from mobile tower. Ground stations for cell phones can be unrestricted towers or installed on existing structures like trees, water tanks, or tall buildings. The antennas must be high enough to cover a large enough region. The height of base stations is normally between 50 and 200 feet. Cell phones connect with neighboring cell towers primarily by RF waves, a kind of energy found among FM radio waves and microwaves in the electromagnetic domain. They are not ionizing energy, just like FM radio signals, microwaves, visible light, and heat. Higher, ionizing, kinds of radiation, such as X-rays, gamma rays, and ultraviolet, UV, rays, are considered to be capable to trigger cancer because they directly destroy the DNA within cells. Heat emitted by room heater. Infrared emission is emitted by the element and passes across air or vacuum until it collides with an absorbing surface when it is partially transformed to heat and partly reflected. Instead of heating the air, this heat immediately heats the people and items in the space. Once you switch on a heater, the electric power current generated warms the nichrome wire elements of the device, also known as the heating coils. As the power flows across the barrier, energy is converted to heat. Electric heaters are sometimes called resistive heating units because of this. Heat emitted from a toaster. To cook a slice of bread, a standard toaster employs infrared radiation. Heat is typically generated by passing power via nichrome wires, joule heating. Infrared radiation is produced when you put your bread in and see the coils light red. The bread's surface is softly dried and charred by the radiation. Frequently asked questions, FAQs. Ks. What are the 7 different kinds of radiant energy? EMR comes in 7 different natural forms. Gamma rays contain the most energy and the shortest wavelength of all the electromagnetic waves. X-rays, ultraviolet light, visible light, infrared radiation, and microwave radiation are the next types of radiation. Lastly, radio waves have a smaller wavelength and the least power. Ks. What is the purpose of radiant energy? ANS. The power of electromagnetic waves is known as radiant energy. The phrase is most generally used in radiometry, solar energy, heating, and lighting, although it is also utilized in various domains less often, such as telecommunications. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.